Hey guys, Mr. Backerberg here. In this video, we're going to look at partial fraction decomposition. In your math career with fractions, you've spent a fair amount of time with adding and subtracting fractions, and in order to do so, you need to get common denominators in order to put them together to create one singular fraction. As we're doing partial fraction decomposition, we're actually going to be working backwards. And here's an example of what partial fraction decomposition looks like. We're going to be starting with a larger fraction or rational expression and taking it and breaking it down into smaller, easier to work with fractions. And each one of these fractions on the right-hand side, these are both called partial fractions because they're part of the initial whole rational expression, that fraction on the left-hand side. So like I said, what we're going to be working on doing is taking a larger, more complicated rational expression and splitting it into a sum or a difference of smaller pieces. So here we're going to look at decomposing this rational expression into some partial fractions. So we've got the rational expression 5x minus 1 over x squared minus 2x minus 15. As we're looking at this rational expression, the first thing I'm looking at is that quadratic in the denominator. And what we want to try to do first in here is factor out this quadratic. So we've got that x squared in the front, so I need a couple of x's leading off my factors. We're going to do sum and product factoring, so we need things that are going to multiply to negative 15 but add up to negative 2. So that's going to be negative 5 and positive 3. Now these factors are going to be really important to us because as we're looking at splitting up this rational expression into these smaller partial fractions, we're going to use those factors as the denominators of our new fractions. So I'm going to put the x minus 5 on the bottom of the first fraction and the x plus 3 on the bottom of the second fraction. Now we don't know what the numerator is yet, so I'm just going to throw some general variables up there. So I'm going to put a letter a on top of this x minus 5, and I'm going to put a b on top of this x plus 3. Now right now, having all of these fractions in here can be a little tricky. So we're going to do some multiplying to help us get rid of those fractions. And I'm going to focus on the factored out version of this denominator on the left-hand side. And what we're going to do is we're going to multiply both sides of our equation by these factors. So we're going to multiply by the x minus 5 and the x plus 3. Now when we do this, we're going to have to distribute this to every single term. And I'm going to write this out the long way for right now so that we can see the canceling that's going to happen. So as we're multiplying these factors by our fractions, we're going to get copies of these factors in the numerator of our fractions. So as we're looking at this first fraction on the left-hand side, we're going to have the 5x minus 1, and we're going to have the x minus 5, and we're going to have the x plus 3. Now in the denominator, I'm going to use the factored out form so that we can see the canceling happening. So we factored that initial quadratic into the x minus 5 and the x plus 3. Now similar things are going to happen on the right-hand side. Each one of these factors is going to end up in the numerator of our fraction. So we've got the a, we've got the x minus 5, and we've got the x plus 3, and this is all over x minus 5. And then with our second fraction, we're going to have the b, the x minus 5, and the x plus 3. And this is all over x plus 3. Now hopefully we're going to see some canceling happening in here. In this big fraction on the left-hand side, the x minus 5s are going to cancel, and the x plus 3s are going to cancel. So the only thing we should have left over is our original numerator, so that 5x minus 1. In this first fraction here, notice that the x minus 5s are going to cancel each other out. So we have the a times the x plus 3. And in our second fraction, these x plus 3s are going to cancel out. So we're going to have the b and the x minus 5. Now I'm going to take this a and distribute it in. So we get ax plus 3a. And I'm also going to take this b and distribute it in. So we get bx minus 5b on the right-hand side. And on the left-hand side, we have the 5x minus 1. Now here's what we're going to do with this big equation that we've got right here. We're actually going to look at splitting this up into a couple of different pieces so that we can build a system of equations to then go through and solve. And the first thing I want to focus on are the things that have the x's in them. So on the left-hand side, we've got the 5x, and on the right-hand side, we've got ax plus bx. Now, all of these have x in them, so what I'm going to do is divide everything by x to cancel out all those x's. So then we get 5 equals a plus b. And then what we're going to look at is all of our things that don't have x's in them. So on the left-hand side, we have that negative 1. On the right-hand side, we have that 3a minus 5b. Now these two equations right here is what we're going to use to solve to find our a and b values. Now we can either do this using substitution, we can do this using elimination, or we could use some matrices to help us solve this. And it really doesn't matter which way you do it, it's more of just a preference thing. I'm going to do elimination on this first one. So the first thing I want to do is write these so that they're stacked on top of each other. So I'm going to take this 5 equals a plus b and write it over here. I think the easiest thing for me to eliminate is going to be those b variables. So in my first equation, I've got negative 5b, but in my second equation, I've got that positive b. So I want to have a positive 5 in there to cancel out with that negative 5. So I'm going to multiply everything in this blue equation here by 5. So then I get 25 equals 5a plus 5b. And then when I add this equation to it, negative 1 equals 3a minus 5b, we're going to notice that those b's will cancel out. On the left-hand side, 25 and negative 1 give me 24, and 5a and 3a combine to make 8a. If I want to solve to get a alone, I'm going to divide that 8 over to the other side, so I should get an a value of 3. Now I still need to find my b value, so I'm going to look over here at this blue equation. We just figured out that our a was 3, so I can plug in that 3 there. So we get 5 equals 3 plus b. Subtract that 3 over to the other side, and our b value is 2. Now we're not quite done here. What I want to do is I want to go all the way back up to our partial fraction breakdown that we started with, this set of fractions on the right-hand side. We just figured out our a and our b values. So I want to write out these fractions with those a and b values plugged in. So we said that our a was 3. So this is the fraction 3 over x minus 5. Plus, we said our b value was 2. So that's the fraction 2 over x plus 3. So this right here, this set of fractions, is your partial fraction decomposition of this original rational expression. Now we're going to look at another example in here. So we've got 3x minus 4 over x squared minus 2x. This is the example from the first slide that we looked at. The first thing we want to do is look at factoring out the denominator. I see that we've got this x squared minus 2x. Each one of these terms has an x in it, so I'm going to take out a GCF, and that's going to leave me with x minus 2. Since these are the factors, that's what we're going to use in the denominator of our fractions on the right-hand side. On top of that first fraction, I'm going to put an a, and on top of the second fraction, I'm going to put a b. Now we're going to do our multiplying to help us get rid of the fractions, and I'm going to multiply by these factors from the denominator, so the x and the x minus 2. Now we're going to need to distribute this in, so I'm going to distribute this to all 3 of our fractions in here. So if we distribute to our first fraction, then on the top we're going to have the 3x minus 4, we're going to have the x, and we're going to have the x minus 2, and on bottom I'm going to use the factored out form, so the x and the x minus 2. In our second fraction here, we're going to have the a, the x, and the x minus 2 over x. And in our last fraction, we're going to have the b, the x, and the x minus 2 all over x minus 2. Now in our first fraction, the x's are going to cancel, and the x minus 2's are going to cancel, so we should just have the 3x minus 4 left over. On the right-hand side with this first fraction, the x's are going to cancel out, so we're going to have the a and the x minus 2. And in our second fraction, the x minus 2's are going to cancel out, so we have the bx. I need to distribute this a in, so we get 3x minus 4 equals ax minus 2a plus bx. And now we're going to split this up to make our two separate equations. So I'm first going to look at the things that have x's in them. So we've got 3x equals ax plus bx. And for our second equation, we're going to look at the negative 4 equals the negative 2a. Now here we're actually going to be able to solve to find our a value right away. So I can divide that negative 2 over to the other side, so we get an a value of 2. In this equation over here, I'm going to divide everything by the x to get rid of the x's. So it says 3 equals a plus b. We figured out that our a value was 2, so I can plug that in right there. So 3 equals 2 plus b. Subtract that 2 over to the left-hand side, and we get b equals 1. But then again, we're not done because we need to go all the way back up to our initial partial fraction breakdown, because now we know what our a and our b values are. We figured out that our a value was 2, so that's 2 over x, and we figured out that our b value was 1, so that's 1 over x minus 2. So this is the partial fraction breakdown of that initial rational expression. And hopefully we notice that that's what we had on our first slide. That's going to be it for this video. Thanks for watching.